Hey everybody, Bill Sky, the assembly guy here today. And I was going to do this particular video in just a single video, but as I was setting everything up, I'm thinking, oh my God, this is not possible to do this in a single video. So what I'm going to do is I'm going to separate this video into three different videos. One video on file systems and files, which you really need to know before you actually get into writing assembler language code to produce files and things like that. And then I'm going to do another video on Linux and then another video on Windows, doing it on Windows. Now, the Linux is actually arguably much easier than the Windows version because the Windows API, Application Programmers Interface, I believe is really poorly documented. So it takes a lot of work. You have to buy a book, or you have to do, you have to rely on other people, which is fine, I guess, but it's just very difficult to find things. On Linux, it's open source, things are available. So we're going to do the file system part, which is what we're going to do today, and then we're going to do the Linux programming and then the Windows programming, and hopefully I'll be able to get all three of these out at the same time out on YouTube. So anyway, let's get going with file systems. Now, first of all, what is a file? A file is really a collection of related data. So, for instance, I'm going to open up and I'm on Linux here, I'm going to open up my documents, I'm going to open up my ASM projects, and each one of these is a file. My main.c, that's a C program, .o is an object file, .s is assembler language code that was generated, makefile, that's how it builds, and this one right here happens to be executable. Now, you don't see as much information in the GUI as you can on the command line, so we're going to look at that in just a moment. But each one of those files is a compartmentalized amount of data for one purpose. This main, for instance, its purpose is to execute things. So you've got other type of files that you work with all the time. Word documents, spreadsheets. The video you're looking at right now, it is basically a file. The contact list on your phone. All of these are stored as files on any computer device, no matter what kind of device it might be. It might be a tablet, it might be a phone. That's just how things are done, and they're done on every operating system that way. They're done, like I said earlier, on every device. It doesn't matter the CPU. Files are what are stored on a secondary storage device, which will not lose its information if it's turned off and then back on again. Where RAM, or the primary storage, which is memory in your computer, every time you turn off your computer, your phone runs out of memory or out of battery power. That memory does not stay there. So there's ways of getting around that a little bit, like if the phone's about to die from no power, it backs everything up out of memory onto a file, but it backs it up onto a file. So files are basically that. They're just a related amount of information that you put into a single entity, which we call a file. Now, where do we store this stuff? I mean, you've got files, but what's the underlying technology? Where there's this idea of what we call a file system. And what I'm going to do here on Linux is I'm going to bring up this program called gparted. Now, I also believe on Linux there's one here called disks, but I'm going to bring up gparted because gparted is a tool that makes it very easy to see what we're talking about here. So a file system is a program which allows the operating system and your programs to communicate with secondary storage hardware devices like hard disks, SSDs, CD-ROMs, DVDs, tape drives. Yes, I said it, tape drives. They're still used a lot out there for backup. Thumb drives, all of those different devices have a file system on them. And what gparted is showing right here is it's showing my devices. If I come over here on the right, I can see that I have an 80 gigabyte device, and you can see this /dev/SDA. That's just an identifier within the Linux operating system as to that device, and then there's also an SDB. That happens to be a USB thumb drive. I'm going to click on that, and you can see that it's unallocated. That means that there's nothing there. So, but if I go back to my SDA, you can see that we've got a FAT32, we've got an ext4, we've got a grub. Okay, each one of those types of file systems do a different thing. They're for a different purpose. And the file system is used by the operating system as a plug-in to the OS. So You can see we've got multiple file systems here. That means that you can connect as many file systems as you want to an operating system as long as it is built for that operating system. What else does the file system do? The file system allocates a portion of your secondary storage device. Like in this case, it's a hard drive, an 80 gigabyte hard drive. It can allocate those into what we call partitions. So there's a grub partition, there's a FAT32 partition, there's an ext4 partition, and here's an unallocated 1 megabyte partition. That probably is there because the operating system, things weren't aligned correctly on the storage device, so, or there might even be control information in there. But the best thing, if you don't know what you're doing on these file systems, the best thing to do is to leave it alone. So what the file system does is it takes that each one of these partitions and it organizes the bits. It organizes the magnetic, I'm not sure what the magnetic material on the storage device in such a way, in blocks, sometimes sectors, cylinders. Those are all things that we're not going to be able to talk about, but are very important when it comes to the architecture of a storage device. It organizes that stuff in such a way where it actually looks like, even though we have a single hard drive here, it looks like there's 3 partitions on it. So those are what I like to call logical drives or logical partitions. So it organizes all that stuff, gets it ready. It's kind of like getting ready to build a house, right? You have to format the property. You have to partition it off. This will be the front yard. This will be the backyard. This is where the house is going to sit. And you get it all ready before you actually start writing the building onto the property. So that's kind of what it does. Now, there's a bunch of different types of file systems. And one of the ways to really see the different types of file systems, I'm going to go to my B here, and I'm going to create a new partition. And I'm going to drop down this drop-down box, and you can see all these different partition types. Here's exFAT, ext2, ext3, 4, HFS. There's even NTFS right there. And we're going to talk about what each one of those are. Or you can create a partition unformatted. In each one of those file systems, I mean, there's hundreds of file systems out there. Each one is used for a different purpose. And most of the time, one operating system will support, like maybe 5 different file systems. Another operating system might support 2. And it's just what that operating system is going to use as a tool to be able to access the secondary storage. So some of the more popular file systems, if I go back up here, there's FAT16. FAT16 was one of the first file systems on DOS. Came out in the late 70s, early 80s. Very, very limited, but it worked. It worked on diskettes most of the time. Then came out FAT32, then exFAT. FAT32 was a 32-bit version of FAT16. Hard drives used FAT32. Then we have exFAT, which is for external devices like USB thumb drives. And then there's other ones like HFS Plus. HFS and HFS Plus are Apple or Mac file systems. So it is amazing that Linux will support HFS Plus file systems. At least it'll format it that way, or gparted will. And then we've got NTFS and NTFS2. Those are Microsoft Windows, the most modern file system. There was another one called HPFS, which was a file system that IBM wrote for Microsoft's OS2 operating system before Microsoft abandoned that. Microsoft and IBM were working together on that. So HPFS was what they call high performance. NTFS is next technology file system. And then Linux, they really work on ext2, ext3, ext4. They also worked on BTFS. Each one of these file systems has different benefits. But today, the ext4 on Linux is the most popular. And like I said earlier, every operating system has a little bit different, has a different number of file systems that they support. So let's go ahead and actually do this. So I have an empty storage device here. You can see it's unallocated. I'm on gparted. And what I'm going to do is I'm going to right click on it and I'm going to say new. And so what we're going to do is we're going to take this 8 gigabyte USB thumb drive and we're going to separate it into 2 separate partitions. And it'll look like you've got 2 different hard drives on your computer instead of just the one thumb drive. So we're going to partition it. So the way we're going to do it is I see right now that the current size of the hard drive or the USB thumb drive is 7437, and that's about 3718. So I'm going to drag this over to 3718. I'm just basically splitting it in half. Okay, there it is, 3719. And I'm going to leave it as a primary partition. You can make it a primary partition, a logical extended. It depends upon what your operating supports. In today's hard drive configurations and partition tables, primary, you can have multiple primary partitions. I'm going to make this one, I'm going to go down to the partition type and say unformatted, and you're going to see why I'm saying unformatted in just a little while. And then I'm going to click on add. So now it looks like we've got two. Now, this isn't available yet. I haven't actually committed these changes because I haven't pressed this little checkbox. So I'm going to click on this unallocated again, and I'm going to right click on it and say new. I'm going to create a second partition. And this one I'm going to also make it unformatted. And I'm just going to let it fill it up. And that's the nice thing about gparted. It'll just say, well, you want to fill up the whole thing. So I say add. So there you go. So now I'm going to press a little checkbox. It says, are you sure? Yep, I want to do that. And it goes through some stuff. You can drop down the details. You can see everything that it was doing. Sometimes it'll even show the commands. You can see right there some of the possible commands there. All right, so now we actually have some partitions. Now, what I can do, and we're going to do this demonstration on Windows as well, I can also delete them. So like, let's say if I don't like the first partition here, I can right click on it and say delete. Notice how it changed to unallocated. And if I press the check mark, it would delete it. But let's just go ahead and leave that the way it is. I'm going to press the undo. And there we go. Now, I'm not sure why gparted shows this one as FAT32. I'm not really sure about that because we really haven't formatted it yet. It's still unformatted. But what I'm going to do now is I'm going to format the partition, because after you divide the hard drive or the SSD or the thumb drive in this case into different partitions, you need to format them to the file system that you want. So I'm going to right click on that and I'm going to say format to, and I'm going to pick, let's pick exFAT. And then I'm going to go to the second partition. I'm going to right click on that and I'm going to format that to ext4. Now, one piece of information here, Windows will not read ext4 unless you buy a product to do that. So you want to think about it as you're partitioning and how you're formatting things. And I'm going to go ahead and just click the checkbox here and say, yep. And it goes ahead and does its thing. Now, there also is something else when you're formatting a hard drive or an SSD or a thumb drive. Sometimes you have the option for what they call a quick format. If you turn that on, what that means is that the file system will format the drive as the operating system uses the storage. And in modern operating systems, modern file systems, that'll work just fine. In the past, we used to have to format the entire drive. Now, that still may not be a bad idea, simply because when you format the entire hard drive, it checks every single bit on the hard drive to make sure it's good. And if there's a problem, it'll go around that bad area. But it can take hours. Like, I have a 80 terabyte external hard drive, and that would take weeks to low-level format that. So, okay, so it's all done. Okay, so now what can we do with it? Well, notice it shows the exFAT and the ext4. I'm going to go over here to, actually I'm going to close gparted, and I'm going to go over here to my computer, and let's see, you can see them right here. Here's my 3.9 gigabyte volume. Here's another one. Now, one thing I didn't do, I didn't label them. So that's something else that you might want to do, is you might want to label the drives. So I'm going to go back into gparted. I'm going to put a label on each one of those. So let's go back to our USB thumb drive. I'm going to right click on exFAT. I'm going to say, oh, it doesn't really have a label feature. Well, let's unmount it. You have to unmount them. That means take them away from the operating system. The operating system cannot actually use them. For now, we can remount them. And I'm going to right click on exFAT and I'm going to say label the file system. And I'm going to say exFAT USB. And click OK. I'm going to click the checkbox. Yep, I want to label it. Okay, and now I'm going to label the ext4. Now this is the label that you'll see when you look at your file manager. So I'm going to label that. I'm going to call this my ext4. And press the checkbox. Okay, So now I'm going to close gparted. Now the reason I'm closing gparted is that when gparted is up and running, it doesn't allow me to look at them in the file manager. That's one of the things I don't like about it. So now I'm going to go back into computer. And there we go. So there's my ext4 and there's my exFAT USB. And I can right click on this. I can say create folder. So it's available. You can do anything you want with it just as like it's another hard drive. Now remember though, exFAT is useful on Windows and Linux and Mac, but ext4 is only available on Linux. Now you can buy add-on packages, like I have one for my Mac, I have one for Windows, where it can access those. But, you know, they're not cheap. I guess maybe they are cheap for what they do. I think I pay $89, and they update about every 3 years or so. So anyway, so there you go. Now, if I want to take those off, I can click this little eject button, and it ejected all of those from there. So that's how you partition and then format on Linux. Let's take a look at Windows. Okay, we're on Windows 11 here. Now, the way that you do this on Windows 11, you don't run a program like back in DOS days, in Windows 95, Windows 98, even Windows NT. There was this program called fdisk, format disk, that allowed you to do it, and it was really a command line tool. So what we're going to do here instead on Windows 10 and Windows 11, I believe Windows 7 was the same way, is I'm going to bring up my Explorer. I'm going to go down here to PC. I'm going to right click on it. I'm going to click on Show More Options, and I'm going to click on Manage. And what that does is that brings up the Computer Management Console. From there, I'm going to double click on Storage, and I'm going to double click on Disk Management on Local. And what you see here are all the drives. Now, I haven't actually connected this USB thumb drive to this window, so let's do that now. All right, so what I had to do is I had to disconnect it physically from the computer and then put it back in, and then Windows saw it. Again, I'm running on VMware guest operating system, so little snafus happen there. So you can see right here that this was the same device that I used on Linux, and there's my exFAT. Windows can see it just fine. But Windows sees that this is a healthy primary partition, but it doesn't know what it is. I can't do anything with it. If I right-click on it, it lets me delete volume, but that's all it lets me do. So, but I'm going to do that. I'm going to go ahead and delete both of these. And that's because I want to show you how to partition from within the Storage Management Console. And I also want to show you the limited number of file systems that you have with Windows by default. So this is our 7.26 gigabyte USB thumb drive, and I'm going to right click on it. I'm going to say New Simple Volume. Next. I'm going to do 3718 megabytes. That's the first half. It allows you to assign a drive letter to it because Windows uses drive letters. It uses anything from A through Z. Now, for your information, A and B, those are normally floppy disk drives. C is normally your hard drive. D is normally your CD-ROM drive or your DVD drive. And things don't normally really start showing up until E. So I can, really the only option here is either mount it this way or assign a drive letter. So I'm just going to leave it as F. And then I'm going to come down here and ask me what file system I want, kind of like what gparted did. I'm going to say do not format the volume. I'm going to say next and next. And here it is. It's still working. It takes a couple of seconds for it to partition it, mainly because it's a USB thumb drive and those are slower. Once it's done partitioning it, it's setting up its file allocation table or its partition table. It'll come back, but it won't show you that you can actually use it yet. So let's go ahead and let that finish, and then we're going to do the second one. Okay, so now let's do the second one. Now we haven't formatted that yet, but I'm going to right-click on this one and say another New Simple Volume. And what you can do also, instead of saying do not format this volume, you can go here and select a file system that you want to format it as. So I'm going to format this one as FAT32. I'm going to give it a volume name, FAT32 USB. And notice here's that Perform Quick Format. Now if I turn that off, it's going to go through every bit on that USB thumb drive and make sure that it's valid. That's a good thing. If you're going to be producing a partitioner, you're going to be creating a partition that's going to be having very, very sensitive or very, very important data on it, you may want to turn that off. But just for this demonstration, I'm going to turn that on. So what this is going to do is it's going to partition the second half of the USB thumb drive, and it's going to format it at the same time. If you notice the one on the left, it says raw. That means that there's no formatting there. Nothing has actually been put there yet. Okay, we got a notifications down here that FAT32 USB was now available. We still have a little, I guess it's cleaning things up, or it's, you know, making sure everything is cool on the USB thumb drive. Now, I don't know, you can do this on the command line. On Windows, because the documentation, I think, is pretty poor, the GUI in this case seems to work better. On Linux, you can do it as well using the command line. But again, because you're dealing with storage devices, it can be very difficult. So I like using GUI programs for that. Okay, so you can see the FAT32. I'm going to right-click on this first one right here, and I'm going to say Format. Now remember, this is the one that we did not format. We just created a blank partition. So I'm going to say Format after I right-click on it. And I'm going to make this one an NTFS if it would cooperate with me. Okay, see, there's some snafus here. So let me go ahead and close that. I'm going to right-click again, Show More Options, Manage. And let's see if we can get that to format a little bit more cooperative here. I notice this on Macs as well. The disk utility on Macs, I don't think is really cooked fully. All right, so here we go. Okay, so here's our raw partition. There we go. So there's our raw. I'm going to right-click on it and say Format. There we go. And I'm going to give it a volume name. I'm going to say NTFS USB. I'm going to make it an NTFS. I could have made it an exFAT. exFAT is, like I said earlier, is compatible with Windows and with Linux. I'm going to do a quick format, leave everything else default, and click OK. It warns you. And that warning I haven't mentioned before. That warning means that everything on that drive is going to be lost. Everything. So you want to be really, really careful when you're doing this. Okay, it looks like NTFS, the NTFS USB is coming there, or is getting, and it's almost done. There we go. So now if I go back to this PC, you can see our FAT32. I can right-click on it, say New Folder. There we go. I can right-click on that and say New, text document. Okay, I'm going to go back to this PC. I'm going to go to NTFS USB, and I can do the same thing. Now, I always get people asking me, well, what is the most compatible file system across all operating systems? Well, there is none. However, the most compatible file system for the most popular operating systems today is exFAT or FAT32. NTFS is proprietary to Microsoft. There is some open source NTFS drivers on Linux. They're not 100%. They're like 99.9999% accurate. Every once in a while, I'll write to an NTFS volume on Linux and Windows. When I plug that into Windows, it says there's a problem with the drive. I believe Windows more than I believe Linux in this case, because NTFS is a Microsoft technology. On Mac, exFAT is fully supported. HFS Plus is fully supported. Also, there's another one on Mac called APFS, Apple File System. That's the most current file system. It was built primarily for SSDs, which is great. But it's not supported on any other operating system. You can buy add-ons, but they're not cheap. Okay, so those are formatting partitions. And now what I want to do now is I want to talk about, once you have a partition formatted, how do you actually look at the files in that partition? And what we're going to do is we're going to do this with Linux first. Okay, so I've got my Linux back up and running. Now the reason I'm going to look at Linux at first is because the Linux file systems are actually much easier to use from a command line point of view. There aren't as many commands. You'll see that when I demonstrate it on Windows. So what I'm going to do is I'm going to go into, I don't know, let's see, do I have anything in documents? Oh, I really do. So I'm going to right click on the documents. I'm going to say open in terminal. And actually, let's go ahead and change the font here so it's a little easier to read. So turn that off, and I'm going to go to, I don't know, let's go to 16. There we go. Okay, so our font is a little bit bigger on the terminal. All right, so I'm going to type in this command ls-al. And what that does is that brings up a list of a detailed list of everything that you really need to know for that particular file system. I'm inside the documents folder. And let's take a look at some of these. Now, this is the part that you're going to need for your assembly language programming because you're going to have to specify some of this stuff when you're creating files. So over here on the left, the D means that that's a directory. That's a folder. So the dot directory means the current folder. The dot dot means the previous folder. Why in the world did they do that? Well, by doing that, I can say change directory dot dot, and now I'm at the parent folder of the documents folder. And we're going to look at the tree in a little while. So I'm going to change directory to documents. And let's do that ls again. Okay, so that's what the D means. If it doesn't have a D, that means it's a file. The next three characters, those are the access specifiers for the owner of that directory or the owner of that file. RWX means that I have read, write, and execute, or the owner has read, write, and execute on that folder. So if we take a look at the CS21 21 install, it's a normal file, but the owner has read, write, and execute authority to that file. The next three RWX in this case, that is the group. So the group that the owner is in, it also, everybody in that group also has RWX. However, if you notice, the group for the ASM projects, they don't have write authority on that folder. They only have read and execute. So by taking away some of those authorities, you're securing the file system. And then the next three, in this case R dash dash, the next three, those are for everybody else in the universe. Do all of those, who else has access and what is their access to that file or that folder? In this case, everybody else only has read access. So that tells you exactly what everybody else can access. You can specify it, and you should take my Linux course when I start doing that this month, and I can show you how to change all that. Okay, so what are some of the other things? Well, the first name right here, that is the owner of the file or the directory. This is the group that that folder or directory is associated with. Then you have the size of the folder or the directory, and then you have the last date that it was created or written to. And sometimes files are better. So this file right here is 5375 bytes in size. It was last accessed or created on September 18th at 0048. That's early in the morning. Yep, that's what I'm doing all day. Now, there's also some, these are what we call octal, the octal number system. You have numbers 0 through 7. So think of these as 3 binary bits. The X is bit 0, the dash is bit 1, and the R is bit 2. So if they were all on, like you see right here, they're all on, that would have an octal value of 7. So the actual octal value for, let's take a look at CS21 install, that would be a numeric 7 for the owner, this would be a numeric 7 for the group, and this would be a numeric 5 for everybody else. Why is that important? Because if you're going to be changing authorities on a file, you do it with the change mod, and I can say change mod, and let's say I want to have the owner has all access and nobody else has access. So the 7 is for the RWX, the 0 is to zero those out, and then the 0 is to zero them out for everybody else. And I'll say CS21 mint 21 install. And now if I do a list, you can see that only the owner has read, write, and execute. The guest does not have, or the group does not have, and the guests or everybody else in the universe does not have either. And that's actually pretty common to do it that way. So that's how you can do it with this change mod. But you can look at information on the internet as to how to do change mod, or wait for my Linux course to come out where we talk about it and we do all that kind of stuff. So those are the octal values. Now there's also another command you can do. I can say stat cs21 mint21 install, and that gives you more information about the file. It gives you the actual size, the number of blocks. You can find that out if you look at a storage architecture video, or look into that. You can see an actual device serial number. Then you can see when was the last time it was accessed, modified, changed, birth, when it was actually created. I'm not sure the difference between modify and change, but there obviously is one, because when I did this, when I made changes, it was on December 9th, 2023, which is when I'm creating this video, but the modify shows is September 18th, so I'm not really sure the difference between those two. So that's how you would do that in Linux, to look at any specific file or files. You could also say ls, let's go back here, ls-al, and I could specify just one file. Now I mentioned something about parent tree, like if you say change directory ... if I say cd ... that will take me to the parent tree. What am I talking about there? Well, there's a neat little utility in Linux called tree. Oh, I didn't install it. So let me install it. Now, you can find utilities like this for Windows as well. But when I type tree ... that means give me the tree of the current folder, or the full current directory. And it kind of gives you a semi-graphical representation of the file system. So within the home folder, my home folder, there's a desktop folder. Inside of that folder are a number of files. In my home folder, there's also a documents folder. Inside the documents folder, there's a folder called ASM projects, and you can see all of my project folders, and you can see all the files within those folders. So that's what I mean by a directory structure, is that it's basically a tree structure that allows you to have directories inside of directories, files inside of directories, and so forth. So that's what I meant by that. Okay, now let's take a look at Windows. Okay, so back on Windows 11, there's a number of ways that you can look at the attributes of a file. And I'm going to go to source repos. This is where your Visual Studio 2022. And I can right click on any file in here, and I can go to properties, and right here it'll give you information about the file. Now you can do the same thing on Linux as well. It'll also tell you, is it read only, is it hidden? There's also some advanced stuff that you can do with the attributes. You can see if there's any security, who owns that file, what kind of control do they have. This is an entire course on Windows security of files. I mean, it's crazy. There's so much here. And then you can see details about the file if there were any previous versions. But there's also some commands that you can issue. So I'm going to bring up PowerShell. I'm going to run it as administrator. Now, one thing I really don't like about PowerShell or Windows is that they've made it really difficult. There's so much. Oh, where do I want to go here? I'm just trying to get to where I was. On the GUI. There we go. We finally got someplace. Okay, so what I can do is I can do a command called get-acl, and I'm going to say ASM 64-bit KF, and I've used mmxtest.sln. And wow, it's not very readable, is it? It just is not very readable at all. And that right there, that particular command, what that'll do is it'll get the owners of the file if you want to do it in the command line. There's also another way to do this, and that's using the get item property. So that first command, I will put these commands in the description of the video, but in that first command, that showed you the owners, but it's not very well formatted. And for those of you that have ever taken a C or C++ course from me, and you see and you complain about the fact, why does he want my reports to always look so well? This is a good example. Let's go ahead and do this other command. And what this command does is it gives you information about the file outside of the owners. So you've got multiple commands. You had that on Linux too, but the Linux commands I thought were a lot easier. And this shows you where the file was. The PS, that's the PowerShell. That's information about PowerShell. It does tell you the attributes, so it's A, so that means it's an archive file. It shows you the version of the file. Is it private? So it does give you a bunch of stuff about that file. But on Windows, I find it much easier just to right-click on the file and do the GUI. However, that's not very much use to you as an administrator or a developer if you're wanting to get the information about multiple files. You only can do one file at a time on the GUI. At least with the command line, you can write a little script or something that gives you a list that allows you to process every single file that you need access to. So again, there's all kinds of commands you can use, but those are the two most common. There's also another command, and I wish I could open. Oh, I can't open a terminal there. There's also another command called dir, which gives you information about it. So the way I was able to get to that very quickly is I just right-clicked on the background and said open in terminal. If you don't have that option there, then you haven't enabled that in Windows, but it is available on mine. You can see these are not the user permissions. User permissions are not easy to set with the command line. It may be in PowerShell for those of you that might be more experienced with PowerShell, but for me, I'm not that experienced with it. Okay, so that is a simple overview of file systems, partitioning, formatting, files. The next thing we're going to do is we're going to look at actually writing assembler language code, first in Linux, then in Windows, on how to actually write to, read from files in different file systems in those two operating systems in assembler language. Hope to see you there.